Today we will be talking about postulates and theorems relating points, lines, and planes. This is section 1-5 in your textbook. The essential question for this section might be, how do we use postulates to prove theorems? You might recall that we have accepted without proof the following four basic assumptions or postulates: the ruler postulate, the segment addition postulate, the protractor postulate, and the angle addition postulate. These postulates deal with segments, lengths, angles, and measures. We are now going to talk about 5 basic assumptions that deal with the way points, lines, and planes are related. The first of these postulates is postulate 5. It states, a line contains at least 2 points, a plane contains at least 3 points, not all in one line, and space contains at least 4 points, not all in one plane. Basically what this is saying is that 2 points define a line, 3 points define a plane, and 4 points define space. Postulate 6 states, through any 2 points there is exactly one line. By the word exactly, we mean just that. There is one and only one line. So that's kind of a crucial word right there, that word exactly. And to emphasize it, I will underline it. Exactly means one and only one. Postulate 7 states, through any 3 points there is at least one plane, and through any 3 noncollinear points there is exactly one plane. Postulate 8 states, if 2 points are in a plane, then the line that contains the points is in that plane. And if you think about it, this sort of makes sense. If you got 2 points in a plane, you have a line containing those points, that line also has to be in the same plane. Okay, our last postulate in this section is postulate 9, and this postulate states, if 2 planes intersect, then their intersection is a line. And if you think about it, you look at a wall and a ceiling, they're going to intersect. What's the intersection going to look like? It's going to be a line. We now are going to talk about theorems. These are important statements that must be proved. They are referred to as theorems. Now the first of these theorems, Theorem 1-1, states, if 2 lines intersect, then they intersect in exactly one point. Now, you're going to see that how this follows directly from the postulates in some of the problems we're going to do later on. The next theorem, Theorem 1-2, states, through a line and a point not in the line, there is exactly one plane. Now the last of our theorems in this chapter is Theorem 1-3, and it states, if 2 lines intersect, then exactly one plane contains the line. Now, as I stated, theorems require proof. However, we're not going to write any proofs right now. We'll learn about writing proofs in the next chapter. Now there's some vocabulary we need to understand here. Several times you've seen the term exactly one, okay? It shows up in Theorem 1-3. It also shows up in some other places, Theorem 1-2 and Theorem 1-1. Exactly one has the same meaning as one and only one, okay? So if you see the term exactly one, it means this very same thing as one and only one, okay? This theorem, the theorem also states that a point of intersection exists. Okay, if a point of intersection exists, that means that there is at least one point of intersection. And the point of intersection is unique, means that there's no more than one such point exists. Okay? So hopefully that helps to explain some of the terminology here. As I stated, we'll learn more about writing proofs in the next chapter. But for now, let's take these postulates and theorems and work with them. Now I would like you to classify each of the following statements as true or false and post the answers in the drop box. Number 1, a given triangle can lie in more than one plane. Number 2, any 2 points are collinear. Number 3, 2 planes can intersect in only one point. And lastly, number 4, 2 lines can intersect in 2 points.